Salutations, Swift Scholars, it's Professor Gallagher, and now that you've got your first full app under your belt and on your device, it's time to fill out a few more of those SwiftUI basics. In this lesson, we're going to cover a bunch of key concepts, including the border modifier, modifier order, backgrounds, padding, ZStacks, VStack alignment, shapes, gradient effects, and much, much more. Buckle up, it's time for big learning. If you're new here, welcome. You might want to check out the course playlist to see how we got here. And because we're going to need a new project with some things to work with, why don't we issue a quick challenge? This should be super easy, but it's a great way to make sure that your learning is still on track and you're remembering things. So why don't you create a new Xcode project named Fundamentals, code the project so that your preview looks like the image at the right. You should know the image and the color and the font size. One hint that you might want is the font weight is black. So why don't you pause, give this a shot, and when you're done, resume and we'll compare answers. So I'm going to launch Xcode, create a new project. This is an iOS app. Click Next. I'm going to name this Fundamentals and save this to my desktop. Double-click the window title bar so I'm full screen. Hide the navigator's pane. Adjust the preview. And we're ready to code. We want to create the image view with the system name property in here, but we want to change the string to Swift. We'll replace image scale with the two modifiers .resizable and .scale to fit. To change the color, we change our .foregroundStyle to .orange. We'll change our text string to "You are awesome." The font will be large title, the font weight will be .black, and the foreground style will be .red, and mission accomplished. Now, if you take a look at our Swift image, we can see that it doesn't touch the sides of the view, and that's because the VStack has a .padding modifier under it. This adds the standard amount of padding on all sides of every view in the VStack. So there's standard padding around all four sides of the image view and padding around all four sides of the text view. Now, you're not going to notice horizontal padding around the text view because text views only take up the minimum space necessary, and the VStack centers views horizontally. So because there's extra white space on the side of the text view, it's not big enough to be affected by the horizontal padding. Now here's something that can be super useful. We can actually observe the padding in the frame of a view by adding a border modifier to our code. So let's add one as the last modifier in our image view. Type .border, and this says this adds a border to the view with a specified style and width. Now this option has just content in here, but if we take a look at the type that this accepts, it's shape style, and you might remember from working with foreground style in an earlier lesson that color is a shape style, so this is where we specify the color of our border. By default, it's only 1 point in width, but if you wanted to, you could enter the optional width parameter to specify the width of the border. We'll skip that for now, so we'll return to accept this, and why don't we set the border for our image to orange, and look at that, we see an orange border around our Swift image, and the white space that we see between the border and the sides of the app represents our padding. So I'm going to copy this border modifier, I'm going to paste it below the text views modifier, and why don't we change that border to red, and you can see that this view is actually hugging the text very tightly. The text view isn't within range to be impacted by the padding. And then below the VStack, just above the padding, why don't I paste in another border again, and this time let's change the color to purple, and look at that. We've got a purple border around the VStack. This shows that it's centered both vertically and horizontally in our app. The white space around the purple border is the padding, but watch this, modifier order matters. Follow me. If we want the border around the padding, we can cut out the purple border and paste it below the padding, and look at that. Now we see that the border is around the VStack and its padding. The border is actually touching the sides of our simulated device. Cool. Now the default for our VStack is actually to align the views horizontally. Now you might wonder, can I align them left or right instead? And we can. Just add parens after our VStack keyword up top, and then pass in an alignment parameter. So follow me. Add parens after the VStack, and then in between those parens. Now if you start to type alignment, code completion recognizes this, but be careful. If I press return here, I get another content parameter in here. The content parameter is actually, if I press return here, it gives me the curly braces, but I've already got that. We don't need that. That would create an error in our code. So I'll Command Z undo, and I'm just going to type in the word alignment with a colon. Now we can use dot notation to uncover the different kinds of alignment, and we see center in here, but center is the default, so we're never going to choose that. But we do see that we have dot leading, that's left justification, and dot trailing, that's right justification. Now that's the case in left to right language systems. If we were in a right to left language system like Arabic or Hebrew, then dot leading would be right and dot trailing would be left. So let's select dot leading and see what happens. In that view that wasn't touching the sides, the text view now touches the left side. It's pushed out with a little bit of padding, but it's even on the left-hand side with our image view. Cool. Change it to dot trailing, that moves things flush right. Also very cool. And now let's temporarily comment out the dot padding line. So the way we can do that is to put a double slash before any of the code that executes on the padding line. The double slash in Swift are the comment characters, and any code appearing after the double slash is not executed. Comments are a really nice way to toggle your code on or off when you're trying to get a sense of what your code does or when you're debugging. So with the padding commented out, I can see both views now touch the side of the simulated device with dot trailing. Cool. And here's a handy shortcut for you. If you press Command/, that will toggle the comments on or off. So every time you press Command/, you either add comments or take them away. Also super useful. Now, it's good software practice to liberally comment your code to provide documentation that describes what the code does. This is really good for more complex code or when you're working in a software development team or when you or somebody else might return to your code to maintain it at a later date. Comments help you understand what you're looking at. You can put comments in if it's useful to have extra notes in your code, but our code isn't all that complicated, so I'm not using a lot of comments in our lessons. And another thing that you can do is you can highlight a whole block of code and Command/ to toggle the comments on or off. So with the text view and its modifiers highlighted, Command/, the commented code no longer executes. We see that Xcode turns it gray. It takes off pretty printing, and we don't see a text view in the preview. Command/ again, and our text view and modifiers are back. Now, we don't need this descriptive code up here, so I'm going to cut that out. And there's also one final way that we can comment a block of code in Swift. It's /* or /* to begin the comment, and */ will end the comment. See how I've surrounded all of my text code with /* and */. Xcode again turns it gray, turns off pretty printing. We don't see the text view in our preview. Cool. But I'm going to remove these comments. In fact, most developers use the double slash simply because you can toggle it on or off really easily with the Command/ shortcut. And before we continue, why don't we get rid of the borders as well? And I'm also going to cut out the alignment parameter after the VStack. And now to demonstrate some more techniques, I'm going to cut the padding modifier out from underneath the VStack, and I'm going to paste it below the image view. So just to show you, there's no padding on the text view, but it wouldn't show because we're using the default center alignment and the text view isn't long enough to touch where the padding is, but we do see some padding around the image view. If I'm on the padding line, I can Command/ to turn the padding off and Command/ to bring it back. And why don't we add some borders around the view so that we can see how things change as we make some changes to our padding. How about adding a green border around the image view and a blue border around the text view? Now, one thing to recognize is that modifier order matters. So right now I have padding in my image view and then I have my green border. If I Command/ to comment out the padding, then we can see that my image touches the green border, no padding. But if I bring my padding back and now I move my padding after the green border, I can see that the white space of the padding is between the green border and the edge of my simulated device because the padding comes after the border. Cool. So now I'm going to delete my borders again, and I'm going to open up the attributes inspector, and I'm going to click right in between the parentheses of padding. Now that should bring up the attribute inspector for padding. Unfortunately, it looks like there's a bug in my version of Xcode. Even though I've clicked on the far right attributes inspector icon, I'm not seeing anything in the attributes inspector. But if I click on any of the other icons in the inspectors tab, then click back on attributes inspector, there we go. And now we see attributes for the image view. And I know that because we're clicked below the image view in our code, and it also says image in the upper left-hand corner of this column. So now with my cursor in between the parens and the padding modifier under my image view, now look to the padding area at the bottom of the attributes inspector. This box in the center of the padding area allows you to specify a specific point value for your padding. Now the default value is 14, so if I enter a 14 in this box and then press tab to accept it, we don't see any change in the preview, but we do see our code has changed. Now it includes the number 14 in between the parentheses following padding. And if I change the 14 to a 30 in either place, make sure that you tab if you're using the attributes inspector. Wow, I more than double the amount of padding! And I see my code has changed and now has the number 30 in between parentheses. Now I can refine my padding even more. If I want the 30 points of padding to only apply to the right or trailing side of the view, I can click on the checkbox on the right of the padding amount and see that padding is now only on the right-hand side. There's no padding on the left, top, or bottom. And notice the code has been rewritten again. The format for writing padding changes in here is the name for the location where padding is applied, dot trailing in this case, followed by a comma, then the number of points of padding that you want. But if you forget the syntax, you can always pull up the attribute inspector and have it change the padding code for you. But wait, there's more. You can add multiple padding statements if you want even more control. For example, you can do this. On the next line, I'll write dot padding paren dot bottom comma 100 close paren, and nice. I get 100 points of padding just on the bottom of my image view. So the first line gives me the 30 points of padding on the trailing. The second line gives me 100 on the bottom. And if you look at the attributes inspector over on the right-hand side, you'll see that we now have two padding blocks, one under the other. Cool. Now let's learn how to change the background color of a view. Now earlier we learned how to set a view's foreground color. We used the backgroundStyle modifier and passed in a color. See how we have orange in here? And we learned this works across different view types. We applied it in the text view with foregroundStyle.red down here. Well, if backgroundStyle works for setting the foreground color, then is there a background style? And here's where it's tricky. There is. It even accepts a shape style, which we learned is a color, and code completion says it sets the specified style to render backgrounds within the view. That sounds like the right thing, but if we pass in .blue in here, we get nothing. So delete backgroundStyle. It's actually a pretty rare modifier for you to use. The modifier we want is called just .background, not backgroundStyle. That'll change the color of the view. Code completion says this sets the view's background to the default background style, but we want to actually enter a color in between the parens. If you select this one down here with a parenthesis and it says style, it passes in a shape style, and we learned a shape style is a color, but it can also be gradients, which are mixing of two or more colors, or even other images. So between the background's parentheses, I'll type in dot. Code completion has a lot of options in here, but if I want blue, I start to type in BL, and hey, look at that. Code completion recognizes that colors are valid in here, and it suggests a list of colors. So I'll select blue, and my Swift is now on a sky blue background. Very nice. Now it's important to remember what we just learned. Modifier order matters. Note that right now our code sets the background to blue before we add padding. But if we move our padding .trailing 30 modifier before we call background blue, then the blue modifier applies to both the image's bounding rectangle and the 30-point trailing padding. See how Swift has modified the padding as blue on the trailing side now too? And again, I can compare the two by toggling back, undoing, and redoing. Cool. So modifiers are applied in order, and the last modifier applies to the view as it's been altered by all the modifiers that come before it. Now it's the same thing for the bottom padding. If we move that above the background modifier, it makes the bottom 100-point padding blue too. Cool. By the way, .background can modify any view. Let's do that with our text view. So start typing .background after all of the text modifiers and look at code completion. We see the arrow and view label in here. Now this means that this modifier, background, returns, that's what the arrow means, a modified view, the view at the end. Now in a previous lesson, we learned that a view was anything you see on screen. Images, text, buttons, those are all views. Now you can select this option with nothing between the parentheses. You're just going to have to click between the parentheses to enter the color, or you can select the option with a style parameter. That's the one I'll choose. Xcode highlights between the parens, and I can start to type a color, .yellow, and we see the yellow background around our text view. Nice! Well, actually it's kind of ugly, but we're just illustrating points with garish colors so that we understand what's happening in our code. And just to illustrate, order matters here too. We can add a padding modifier after our background modifier, but if we move that padding modifier before the yellow background, we see that the yellow background is applied to the padding as well. Excellent. Hopefully you're getting this down. So I'm going to undo this. I'm going to show you another useful keyboard shortcut. If you press Option Command open square bracket, that moves the current line or selection up one line. Option Square close square bracket moves the line or selection down one line. And again, these shortcuts can apply to a selection of code. I'm going to highlight my text view and all the modifiers below it. And if I use these keyboard shortcuts, you can see that I can move this above the image, and I see the change in real time over in the preview, and I can move them back down. Now here's another important way that order matters. I'm going to move the backgroundStyle modifier that's underneath image, and I'm going to move that above the resizable modifier. And we immediately see there's a problem. If we look above the preview, we have this message that says failed to build, and whoa, we get another error, and not a friendly one. Clicking on the little red error ball will reveal a full error. It says value of type SumView has no member resizable. Now here's what's going on. Resizable works on an image. If we take a look at the description that shows up in code completion for resizable, we see an arrow and then the word image. That says that the resizable modifier returns a modified image view. Now backgroundStyle can modify and return any view, not just an image, but also buttons, text, or any of the other views that we could create. So since resizable is narrower, it returns just an image. That more specialized modifier has to go ahead of any of the more generic modifiers that could be applied to any view, not just an image. So be sure to add all of your specialized modifiers, like resizable, which only works on images, before adding modifiers that work with any generic view, like the foreground color does. Now, errors in modifier order are easy to make. They happen to even seasoned SwiftUI developers all the time, but hopefully now you know how to look at modifier order and return type if this happens to you. So I'll move the backgroundStyle modifier back to where it was before, and the error goes away. And now that we're done learning about padding, backgrounds, and modifier order, I'm going to delete the garish blue background and the extra padding that were in my image view. And under my text view, I'm going to get rid of my padding and background, and I'll add some generic padding with just the empty parentheses below the VStack. Now some of you curious ones might wonder, hey, what was that background style that we saw before all about? Well, let me show you one example, but I'll also point out what I think is a better way to get around using background style. Again, you use it very, very rarely. I almost never use it. And showing you another technique will give us a chance to show you some neat tricks with shapes, gradients, and ZStacks. So first, let's show that background style. Below our image, let's add a .background modifier again, but instead of choosing the option with shape style to add a color, let's choose the option with the in parameter. This accepts a shape. Code completion says that this sets the view's background to a shape filled with the default background style. Well, let's select this to add a shape, and Xcode says a shape can go in here. What kinds of shapes? Well, we'll ask our buddy dot notation to uncover this, and hey, we see a lot of options in here. Let's try a circle, one of my favorite shapes. And we see nothing. And we see nothing because we used a background, and code completion said we were using the default background style. Well, if we haven't set a custom color for our background style, the default background style is transparent or dot clear. Nothing visible, but we can add a new background style, and we can do this with the .background style modifier. So let's do that now. Now choose the option that lets us provide a shape style. Now we know color is a shape style, and if we enter .blue, we see a circle behind our Swift image. Nice! And here's another trick to achieve a really sweet color effect. If after any color like .blue, we enter .gradient, SwiftUI will generate a gradient that fades from a color that's slightly lighter to slightly darker than the base color. It's very subtle, but it's a nice design effect. But this isn't too nice because our Swift is hanging over the edge of the circle. So how can we clean this up? Well, actually we can shrink our image from the size that takes up all of the space available by using a special modifier below .resizable and .scale to fit. So this new modifier is called a .scale effect. And I don't think the description is very accurate in here. I think the best way to think of scale effect is you can enter a multiplier in here, and that value will multiply by the width and the height to scale it up or down. A scale effect number greater than 1 makes the image progressively larger, and a smaller value will scale it down. So let's enter 0.6 in here. That's the equivalent of getting an image that's 60% of its original size. And look at that, we've got our Swift over a nice blue gradient circle. Very fancy. But I'll show you the technique that I prefer. So I'm going to highlight and delete the background, background style, and also the scale effect. And I want to introduce you to a new friend, the ZStack. So while the HStack allowed us to order things horizontally and the VStack allowed us to stack things vertically, a ZStack allows us to place items one on top of the other. The first item in a ZStack's curlies will be the backmost item, and subsequent items further down in the ZStack will be placed one on top of the other. So let's try this out. Just inside the VStack, above the image view, let's enter ZStack, capital Z, capital S, with open and close curlies. And then let's cut out our image view with all of its modifiers and paste it between the ZStack curlies. Nothing yet. We get a stack of one view. But inside the ZStack, let's add another view. If we enter this up top above the image view, it will go behind the image view. Let's enter a view for the circle shape. That'll be a view. We just say circle with a capital C, empty parens after it, and it's starting to look a bit like what we had before, but the circle has no color specified, so the default is black. But we can change the color, and to do that, we add a .fill modifier. Now, there are a bunch of options in here. We want the one with a content parameter, because if we look at code completion, it says that this takes a shape style, and we know that color is a type of shape style, so we'll select this. And for the shape style, why don't we add .blue, and we'll kick it up with a .gradient after that .blue, and now you've got the nice effect that we had before. Now, perhaps, curious skilled one, you're wondering, could I also use .foreground style here? And yes, you can. It will produce similar results, but if you use .fill, you do get the ability to chain together some more shape-focused modifiers. For example, here I'm adding a .stroke modifier with a red line of width 10. The stroke modifier won't work with foreground style. Feel free to try that out on your own. And we know how to shrink that Swift. If we add a .scale effect to our image view after resizable and scale to fit, we'll pass in 0.6 like we did before, and sweet Johnny Ive, will you look at that? We have the same look, but now we know how to use a ZStack, the color shape, and how to use the .fill modifier to fill that shape with a particular color. Magnificent. Oh, and let me close up the Attributes Inspector. Frankly, professional iOS developers almost never touch the Attribute Inspector, but I thought it was nice to show here because it gave us an opportunity to show how the different padding parameters work. Sometimes I forget what those are, so it's nice to know that you can pull up the Attribute Inspector if you need to. Now let me show you one more useful modifier for ZStacks. Sometimes your objects don't align perfectly. You want to shift them around, left or right, up or down. Well, the first thing to be aware of is the iOS coordinate system starts in the upper left at 0, 0. Positive X values move right, positive Y values move down, and negative values move in the opposite direction. Once we know this, we can shift a view's placement by using the .offset modifier. This allows us to give X and Y values for displacement. Let's try this now. So under the image view, I'm going to add a .offset modifier, and I'm going to move my arrow keys down to this value that has X and Y. I'm going to hold down the Option key. We can see both the X and Y value are highlighted, so we can press return. X and Y are entered, and if we add 40 and 40 for X and Y, we see we've shifted the Swift to the lower right by 40 points in each direction. Let's delete this and see what happens if we want to shift things up. Well, to do that, we can just enter the Y value for offset and add a -25, and look at that, the Swift shifts up. Nice. Let's delete the offset and look at something else. If you hover your cursor over the preview device at the bottom of the preview, you can select various devices in here. Let's see how our code will look on a much larger device. How about an iPad? Any size should be fine, and Xcode might take several seconds to render this because it takes a lot more processing power to preview on a simulated larger device, but eventually you'll see, hey, the preview shows an iPad's dimensions. Nice. Now our text remains in large font, so it looks smaller on a larger device screen, but our logo expands out to the edges of the device except for the padding that surrounded the VStack. Now if you want to keep the logo a specific size, you could use the frame modifier. We learned how to use that in an earlier lesson. If we apply the frame to the ZStack, it'll squeeze everything inside the ZStack to a particular frame size. We could add a frame with a width and a height by saying .frame, but before we press return, we can say WI and HE. We see those two additional parameters are added, and we can tab between these two values at 200 and 200. It shrinks the image down. Very cool. And if you wanted to, we could just set the width to 300, since the circle has the same width as it does height. That'd give us 300 by 300, and we can switch our preview device back to the flagship iPhone, and this looks great. Now remember, Swifter, the first item in the ZStack is in the back, so if I move my image to the top of the ZStack, the larger circle overlays the image and we can't see that Swift at all. And I'm fixing my indents, and oh, I can see that my preview paused as I was moving my indents around. So here's another keyboard shortcut to know about. You often want to restart the preview, but you don't have to click on the circular arrow in the upper right-hand corner. You can simply press Option Command P. That restarts the preview, and we don't want the image in back of the circle, so let's move the circle back to the top. Our Swifty logo looks great, and of course, we've had a ton of big learning in this lesson. We learned about the border modifier, really helpful for understanding how our views render and for debugging layouts. We learned about modifier order and how this influences the rendering of modified views and how return type can dictate modifier order. We learned about the padding modifier and various ways to change and customize padding. We learned about VStack's alignment parameter with dot leading and dot trailing. We learned about comments with // and the group comment with /*/. We learned how to set color with background. And we also learned a bit about the lesser used backgroundStyle modifier. We learned about background in, where we could pass in a shape. We work with the circle shape, the fill modifier, the cool gradient effect on a color, the scale effect to shrink or expand a view like an image, the ZStack, the iOS coordinate system, and the offset modifier to shift things in the X and Y axis. And we learned a bunch of keyboard shortcuts, including Command/ to toggle comments on or off, Option Command open square bracket and close square bracket to move blocks of text up and down, and Option Command P to restart our preview. Swifty legend, you're getting those SwiftUI fundamentals down. Be sure to come back for more goodness and continue to hack.